Good morning, guys. All right, so we're going to carry on with doing our area of triangles. So yesterday we did the area of triangles that have got a right angle, so they've got a 90-degree angle. These are quite straightforward because if we look over here, it is essentially half of a rectangle. So if we just worked out the area of the rectangle and then divided by 2, we could work out what that half is over there, that triangle. So over here we would just say the base times the height, so 3 times by 2 would be 6, but then we know it must be half of that, so it's 3 meters squared. The actual formula we should be following is actually half base times height. Okay, so it's half the base times the height. Then we know that we're dividing it by 2 and we should get our answer. But now what happens if you get to a triangle like this one? Now this one doesn't have a right angle triangle. You can see, if I were to draw the line straight, there's the right angle. This is a very, very big angle. It's greater than 90 degrees. So what happens in this case over here? Now normally in your test or your exercise, what they would do is they would extend the line, dot it like this, so they would put an imaginary line, and then they'd see over there, there's the perpendicular height. So what you would have to do in this case, they would give you this whole measurement for the base, and then they would give you this measurement for the perpendicular height. And those are the measurements you would use. So let's say that this is 3 meters and our base is 4 meters. So again, remember the formula is half base times, and now we're going to include the perpendicular height. So what that means is we've taken half of the base, because remember we're using half of a rectangle, and then we're multiplying it by the right angled portion, the perpendicular height. So perpendicular, remember it means it sits at 90 degrees to the base. So that's that height over there. This side over here isn't sitting at 90 degrees. So we have to use this one over here. Okay, so let's plug in those amounts. So let's say half the base is, so we've got 4, so half of the base is 2 meters, times by the perpendicular height over here is 3 meters. Right, so our answer would be 6 meters squared. That's our answer. Right, let's have a look at one more. So over here we've got another triangle, but again, we don't have any perpendicular heights or 90-degree angles. So normally what they would do is they would draw one coming down and they'd fill in the measurement. So we know what our base is, 5 meters, and we know our perpendicular height is 2 meters. And those are the two we'd use. So we can't just use base times height anymore. That's just a very basic formula to start off with. We know we're using half base times perpendicular height. So let's plug in those amounts. So we've got half of 2 multiplied by 5. Let me explain what I've just done over there. Because 5 is an odd number, that's the base. For me to plug in the 5 on this side over here would be very hard, because then I'd be working with 2.5 times by 2. So to round off and to make it an easier number, you can actually swap those around. Because we have a multiplication sum, it's easy just to swap our numbers around. We end up getting the same answer. So I'd rather half 2 and times it by 5. It's much easier to work with. So we know half of 2 is 1, and 1 times 5 is 5. And of course it's meters squared. Now lastly, let's have a look and check that y. If I had to put 5 over here and 2 over there, so that would be half of 5 is 2.5, and times by 2. 2.5 times by 2 is still 5, so we get the same answer. So what I do is I normally swap my base and my perpendicular height values around, depending on how it's going to be easier in my sum. Okay, guys, I'm going to put a couple of one for you to try below this. All the best.